All right. Good afternoon, everybody. I'm trying to show my screen. Okay, there we go. I got it. Thanks for joining us today. It's our last webinar for our 2019 edition of Lubruary. It's been a fun month. Seeing a lot of interest in this topic, so clearly it's a good thing for us to focus our attentions on. So we've had some fun, and it won't be the only time we hear about lubrication throughout the year, but it is kind of the month where we do turn all of our attention to it. But today we've got Terry Harris, and I think some of you have probably been on webinars before where Terry has joined us. A lot of topics about lubrication storage and best practices, things like that, selection, things like that. But today he's rolling out a new topic, at least for us, talking about lubrication for aging assets. So something that I think a lot of folks are probably dealing with in their facilities. So we're looking forward to hearing what he has to say about that. Before I turn things over to him, just our typical housekeeping. So Terry is letting us record this, which is great. So we will we'll record it and we'll put it up on our website after this is over. And anybody that wants the link to it, I can, just shoot me an email. I'm happy to pass that along to you. So if you've got to hop off early or you've got colleagues that just couldn't make it, we can make that available so you can have a listen later on when it's convenient. We definitely welcome questions. So there's a little questions box. So definitely be typing those in throughout the presentation. I'll be keeping an eye on those, and I'll get those questions tossed over to Terry throughout the presentation if it makes sense. Otherwise, of course, we'll spend some time at the end doing a little Q&A. And then also always like to remind that, since we are doing this live, just bear with us if we have any technical issues, internet issues, audio, things like that. We'll try and get those things resolved as quickly as we can. I know I got nervous earlier this week with all that wind. I did lose power for about an hour, and I was thinking, well, it's a good thing it's not Wednesday. So hopefully, knock on wood, we won't have that today. But like I said, just bear with us, and we'll do our best to resolve anything that might pop up. Before I turn it over to Terry, just want to kind of give him a little shout out, a little marketing pitch. But Terry, lubrication isn't the only thing that he's got experience in. But he's actually got a whole series of learning sessions that are all online, similar to like a webinar like this, that he's got planned out throughout the whole year. So we can send you some more information about those after this, but just something to think about as you're listening to Terry talk. Things like FMEAs and precision alignment, root cause analysis, asset criticality. He's got those kind of mapped out throughout the year. So as you're listening to Terry today, just think, there's a whole lot more you can learn from him. So we'll be happy to share some more info on that. But just like to give him a little shout since he's so nice to do these webinars for us. So with that, now that I've buttered him up, we'll turn things over to Terry and let him take it away.
All right, welcome everybody, and appreciate you guys taking time out of your day to join the webinar. Hopefully I can present some things here that'll help you with any issues you're having with your aging assets. So again, welcome. So again, just a little bit about me. Maureen gave a little bit, but this is some of the things we do as a company. We do predictive and proactive maintenance training. We do a lot of things around lubrication with audits and training programs. And you can see down the list here, we've actually built plug and play lube storage rooms. We built filter carts. We help people with RCM processes and PM training. So lots of things we do in the company. But to get on with what we're going to talk about today, and the reason that people come to webinars, the reason people come to a lot of the training courses, it's about competition. And if you look at this picture of two vehicles here, we see a Lamborghini on the right. I'm not sure what it is on the left here. But I always ask the question in competition, if we were going to bet on a race with these two vehicles, who would win the race to the top of the hill? Well, most of us would probably put our money on the Lamborghini on the right. But then if I ask the question, what are the factors in winning a race? So let's say the race was going to be all the way across the US, all the way across Canada or Australia, would the vehicle on the left have a chance? And the answer would be yes, if we look at some of the factors. And, one of the main factors I talk about when I go to do training at plants is doesn't make any difference what operator you put in each vehicle or how good your operators are operating your plant. So if you put the wrong operator in the Lamborghini on the right, you may not even make it to the top of the hill. And then I always ask about, does it make a difference what kind of maintenance we do to these two vehicles or to our operation? And the answer to that question is yes. If you do the wrong maintenance or we don't do the correct maintenance on the Lamborghini on the right, it may not make it across the whole country or across the whole state. If we do really good maintenance to the vehicle on the left, it may make it across the country. Maybe not as fast, but it'll make it. And then if you look at the cost of maintenance, so I said, what's the cost of maintenance to maintain these two vehicles? Well, it probably costs more to change the oil in the one on the right than it would be to buy the engine for the one on the left. So lots of factors go into how competitive we can be in our facilities. So the last question I'll ask you about this picture is, which one of these pictures is your facility? How many of you are at a brand new Lamborghini type facility where everything's brand new, everything's is the best that money could buy? Well, the answer would be very few of you. Most of us are at these plants that are anywhere from 30 to 40 to 50 years old. I've been in soybean processing plants that are approaching 60 years old now. Well, those plants can compete because they do maintenance well, or if they can improve their maintenance, if they can improve their operations. And so some of the plants that we have in our systems and some of the people that are on this call today are at those kind of facilities. So how do you compete with this aging equipment and all the things that's going on around that equipment in your plant? Well, we have to operate, maintain, and do things correctly. So again, to know where you're at, how do you compare with similar business types? Do you have measures in place to compare yourself in the industry? Where are you doing in the industries you're in? And at your facilities, is there a way to measure yourself to see improvement? A lot of facilities I go into, that if I go in to do an RCM or some other process, I always want to know what you're doing when I get there. And I spend a lot of time on that up front to see what you're measuring, to see how accurate things are. One of the questions I always ask is, how much reactive maintenance are you doing at your facility? And what's that definition of reactive maintenance? A lot of people will throw out a number, well, 60% or 50%. Well, what I want to see is some data. I want to know what that data is to tell me what your level of reactive maintenance is. And then what are some of the metrics? One of the metrics that Cargill uses, they do a maintenance cost replacement asset value. So if they know the replacement asset value of that facility, they know that their maintenance cost, no matter what business unit they're in, their maintenance cost should be no more than 3% of that replacement asset cost. So they use that number to measure and scale every one of their facilities, and they try to drive that cost down to that 3%. So that's a measure they use worldwide. And it actually works in all industries, that 3% number. So again, we have to know where we're at. So some of the fundamentals of the session we're going to do today, there's three things we want to talk about today. It's understanding your current equipment conditions. And how do we do that? So we have all this aging equipment. What's the current condition of that equipment? And then what are some of the failure modes around aging assets that we need to actually watch and monitor? And a lot of these are going to be around lubrication. We're going to spend some time talking about how lubrication affects some of these failure modes. And then at the end, we're going to talk about what are some potential remedies? What are some things we can do in our lubrication program or in our maintenance program to mitigate some of the failures that may happen, or some of the failures that may be happening in your aging equipment. So that's some of the things we're going to talk about today. So some questions, when I go into plants, how old is your equipment? Some plants the plant facility may be 50 years old, but some of the equipment may be new. But a lot of times, and you get into old paper mills and things like that, some of the equipment in there is 50, 60 years old. So you kind of want to know that, and you have to ask that question yourself. And then do you know what condition your equipment components are currently? And a lot of times we're not doing enough tracking with the predictive tools and with some of the techniques we can use to know what condition the components are in. Now, components, when I talk about components in a plant, I don't usually talk about a motor or gearbox. I talk about the components that are inside those kind of equipment. What's the condition of the bearings inside of a gearbox? What are the conditions of your bearings or your windings and things like that in an electric motor? There's technologies and tools that will tell us that, but a lot of times we have to know what that condition is. Where are we at currently? Then if we get into lubrication, what are your lubrication specifications? And the reason I ask this question is because a lot of specifications that were designed for lubrication that's 50 and 60 years old, well, lubricants have changed a lot in the last 50 years and really a lot in the last 10 years. So, things like what the OEM may have recommended back in 1970 for a viscosity may be different today, and we'll talk about some of those things. Additive packages, every one of the lubricants you use in your facilities, if it's a mineral-based lubricant, it has some additive package in there. And I'm going to show you what these additives are and what they're doing to protect your equipment. But what is that additive package that was recommended 20 to 50 years ago? And what are the new additive packages that we can get at our lubricants today that may help our components last longer? Cleanliness code. There was no cleanliness codes back even, and I don't even think an equipment that's even over 15 years old, about how clean the oil needs to be in this equipment. And one thing that's really shocked me, and it's kind of hurt me in the industry, was to find out that a lot of manufacturers don't give those cleanliness codes for one reason. They don't want the equipment to last long life cycles. They love to sell spare parts. And this is one of the things, back in 2006, I was at a plant. And when the plant manager told me, when I was talking about improving the reliability of the equipment, and he told me that this is equipment they were building for customers, he reminded me that 60% of his profits were from selling spare parts. So he had no intention of making his equipment more reliable or telling his customers how to make the equipment more reliable. So this is when I figured out, well, I better be doing this because our vendors are not going to do this for you. But older equipment doesn't have some of these cleanliness codes. What's the change out frequency? How often do you change the lube? And how or why were those frequencies developed? I've been in plants where they say I change the oil in my gearbox every 6 months, or I change the oil in my gearbox every year. Alpha Laval is a good example of this. The plant that I came from, you're supposed to change the oil in Alpha Laval centrifuge gearbox every 30 days. Well, we did that for 15 years until we finally asked the question, why are we changing it every 30 days? What should we be doing? Well, we should be doing some oil analysis to determine when we should change the oil, not just on a frequency. And some of the frequencies may be too long. We maybe should change it earlier. So again, some training around this will help us determine why that frequency is right or wrong. What are your ambient conditions? And this is one of the things I look for. I go into a lot of facilities like steel mills, fertilizer plants, and other things that have high foreign material concentrations. Well, this may determine how we filter the oil, how often we change the oil. I've got a lot of facilities like at a roofing plant where they're making roofing shingles, where they actually spray water on the shingle material to cool it off after they put the tar and the gravel on. Well, a lot of that water ends up going across bearings. These bearings are failing due to moisture. So we did some things with better sealing and some other things to keep the moisture out. So what's the moisture? Where's it coming from? And how's it affecting your equipment? One question that comes up when you talk about viscosities is the equipment outside, where it can be 100 degrees in the summer or minus 20 in the winter. Those are temperature extremes that most lubricants don't handle very well in the viscosity area. Maybe the equipment's inside, stuffed back in a corner where it may be 120 degrees all the time. Well, this is going to change the ambient conditions around that equipment. So if it's in a high temperature or low temperature, these are all could be temperature extremes that are affecting our equipment life on our aged equipment. So if we look at viscosity, we talked about that just a second ago, but it's the most important property of lubricating oil. Viscosity is defined as a lubricant's resistance to flow at a specific temperature. So we all kind of know in the back of our minds and from what we've read that viscosity changes with temperature. But improper viscosity in our equipment, especially our aged equipment, can result in component wear. It can result in improper film thickness. It can result in over temperature sometimes if viscosity is too high. It can result in poor circulation on critical components that need good oil flow through the component. Lots of negative effects around viscosity. But again, viscosity is not only affected by temperature, it's affected by the amount of moisture that gets in your oil, the amount of contamination, lots of things. Age is going to affect viscosity. So we got to take extra care around our equipment, especially equipment that experiences wide temperature fluctuations, or the equipment that the OEM never asks you the question, where are you going to install this when they sell it to you? It may make a difference on what viscosity your oil is. So I'm hoping everybody on the call here understands the different ISO grades of oil. So this would be this top line here is an ISO 150 oil. So it would be like a heavy hydraulic oil or light gear oil. But if you look at the chart here, it's only ISO 150 here at 104 degrees or 40 degrees centigrade. That's the only time that oil has got a 150 viscosity. As the temperature increases, we go up to 140 degrees, our viscosity goes all the way down to 58. At 175, that oil viscosity is 28. And at 215, the viscosity is all the way down to 15. So what happens when a bearing or a gearbox starts failing in your plant? What happens to temperature? And of course, the temperature goes up. And as the temperature goes up, we lose our viscosity. So it's kind of a double failure effect here. You lose your film strength, you lose your viscosity, and the component's going to fail a lot faster. If we look at our ISO 50 or ISO 150, look what it does at even 68 degrees. Look how heavy it gets. Well, if you've got equipment that's outside in the wintertime and it's 0 or minus 20, your ISO 150 oil is going to be thick like molasses or syrup. If you look at ISO 220 gear oil, you can see the same effects here. Viscosity goes way down with temperature, excuse me, and it goes way up as it gets colder. So these are all things we have to look at in our plant. What's the temperature of the equipment as it's running in your plant? And then we can go back to a chart and see what the viscosity actually is at that temperature. This was an example of one of my customers. He said he had some hydraulic units. The OEM recommended ISO 46 hydraulic oil. But when I went out in the plant and read the temperature on the hydraulic unit, it was 148. So this was the actual viscosity of his hydraulic oil. So if we looked at ISO 68, well, at 150 degrees, ISO 68 is only 32. We ended up actually putting ISO 100 hydraulic oil in these units. You know, you started getting more capacity and actually less leaks. So again, we always have to look at viscosity. What is it actually doing at the temperature the equipment's operating at? Now these charts you can get off of Google. I pulled this one off where people will say, well, how do I know what the viscosity is going to be at a certain temperature? Well, this is in centigrade down here, but 40 degrees centigrade is 104 degrees Fahrenheit. If we go up to our ISO 150 line, we see it's only ISO 150 at that temperature. As the temperature goes up, we can see what it does. The viscosity goes down. So if we get up around 70 degrees Fahrenheit, you can see our viscosity is way down. If we get up to 100 degrees, which is 215 degrees, our viscosity is down around 12 or 14. But look what happens to viscosity at 0 degrees centigrade, which is 32 degrees. Look how thick the oil gets at 0. I mean, it's up there where it's now it's turning into molasses or syrup, so you're not getting good lubrication qualities when the oil gets that thick. So I put this chart in here. What's the advantage of using synthetic oils? Well, if you take a standard PAO synthetic, we can see our curve is a lot flatter here. The red line is the PAO synthetic. So synthetics they won't get thin when they get hot. They won't get real thick when they get cold. So synthetics, if you got high temperature extremes or critical aged equipment, synthetics may be the better choice for you. You can see here there's a huge difference in the temperature drop or the temperature viscosity change based on temperature. So again, this is one of the things I always tell people: change to a synthetic oil, especially on critical equipment that may have temperature variations. One of my customers in Canada, I remember when I got there about 5 or 6 years ago, every spring they drained the oil out of their outside gearboxes and they put a heavier oil in. Every fall they drained that oil out and they put a light oil in. Well, I showed them the cost effectiveness of just putting one oil in there that's a synthetic that covers all the conditions because it doesn't change through the temperature ranges. So again, all these curves, like the one I just showed you here, all these curves are on Google. You can type in ISO viscosity curves or of mineral oils and petroleum oils, and these go all the way up to 460s and 1000s if you need to go that high. So this is something that few people understand this and how it can affect your aged equipment. So some lubrication terminology. How clean is your oil? We talked about that. So here's our ISO 4406 code. This was a code established to grade the number of particles of a particular micron size that are present in your lubricant. So what this number means, it's a 3-digit code. So let's say your lab comes back and tells you have a 21, 19, 15 oil. Well, the first number in that number, the red number, represents the number of particles that are in your lube that are larger than 4 microns. The 19 number in the middle, the second number, is the number of particles in your lubricant that are larger than 6 microns. And the 15 number, the green number, is the number of particles in your sample that are larger than 14 microns. Now this is the number of particles in a 1 milliliter sample. So that doesn't mean there's 21 particles, but when we get our lab result back, we have this chart here, and the 21 number says there's somewhere between 10 and 20,000 particles in a 1 milliliter sample that are larger than 4 microns. There's somewhere between 2,500 and 5,000 particles in the sample that are larger than 6 microns. And our 15 number means there's somewhere between 160 and 320 particles larger than 14 microns. So if you look at a loaded bearing or a loaded gear, the average film thickness on a loaded bearing or a loaded gear is 5 microns. Sometimes it'll go up to 10 if it's lightly loaded. Sometimes it could go down to 3 if it's heavily loaded. But you can see if I've got a 5 micron particle in here and I've got 160 to 320 14 micron particles, your component are going to grind those particles up. Those big particles are going to cause wear. So what we're trying to do in our lubricants, especially in our aged lubricants, is keep all these particles out. So if you look at some ISO codes here, here's a one that's similar to what we looked at 211917, but look at the number of particles, 10 to 20,000 in small ones, 2,500 to 5,000, 640 to 1,300 particles in a 1 milliliter sample with this ISO code. Now, if we build a lubricant or a filter cart, we put these 10 micron beta 1000 filters on it. Now we get down to this 16, 14, 11 up here on the upper right-hand corner. But look how much the particle counts have been reduced. So the cleaner we can get our oil, the less wear we're going to have on our components. And this is very, very important on aged equipment, because sometimes our aged equipment already has some wear on it. It may not be to the point where it's far down the failure curve, but the cleaner we can get the oil in our aged equipment, the longer those aged components are going to last. We need to get those particles out. Now, visually, if you look at a sample, this sample on the left here is a sample of oil that's a 221917 oil. And this picture was taken under a 100 power microscope. And this came from a Cargill plant, but you can see all the particles. There's some particles of rust. There's a piece of brass here. There's a piece of steel. And then there's all kinds of just little particles that your equipment is more than likely ground up. But when you see little parts of steel here, these shiny ones, little specks in here, those are usually iron particles, often could be bearings or gears. You start seeing too many of those in the slide and it tells us we got some wear. But look what happened at this facility. We took this oil in this gearbox, we filtered it with a 10 micron beta 1000 filter, and we sent the lab sample in. Well, now the lab sample comes back, it's a 17, 14, 11. But look, there's hardly any particles in here. So how much longer will this gearbox last if we can keep the oil like this rather than what it was when we check it like this? Now, over time, if we wouldn't have caught this, this would have got progressively worse. These numbers would have went higher. But what we did at this plant, we took a sample every week, and we found out that it takes 2 months to get from the clean one on the right back to this condition. So this plant here actually filtered this gearbox with a filter cart every 2 months, and they kept it in this condition. And guess what happens to the life of the gearbox? It increases drastically. I think the last time I heard they were at 3 times more life just keeping the oil clean. So critical for your aged equipment to keep your oil in tip-top condition, keep it clean. And one of the things I don't talk much about on this presentation, but just remember your new lubes coming in aren't always clean. A lot of times you'll see new lubes come in at a 19, 18, 16, and your new lubes need to be filtered. So what about sampling? You know, proper sampling of the oil that's in your equipment. And then how do we understand the results from the lab? You know, let's say it's good, what additives can be used? If the results are bad, how bad are they? Is the viscosity correct for the application? Now, this has only happened a few times in the last 5 or 6 years, but Justin and I were at a plant where somehow the lubricant drum said ISO 220, but the oil that was actually in the brand new drum was ISO 150. That's a mistake made at an oil vendor. I'm not going to mention the vendor's name because I'm hoping it's not a common thing, but you know, if it's supposed to be ISO 220 in a gearbox and they would have put the ISO 150 in the gearbox, which they actually did, we got it changed out right away, that gearbox would have failed it a lot earlier stage because it wasn't the right viscosity for the application. You know, if you're doing sampling techniques, what are the ambient conditions around there? What might you see if there's high foreign material in the area? We may see high particle counts. If there's high moisture in the area, you know, a lot of times down in Texas, Louisiana, along the coast, the humidity is high all year long. So a lot of times they have lots of moisture issues. So we have to understand what's in our lubricant from our sampling techniques so that we can make some corrections along the way and maybe change our lubricant or change the way we do things, better filters, better desiccant breathers. But if we talk about lubricant additives, so let's say this blob in the middle is our lubricating oil. So let's say if we have hydraulic units, the hydraulic units may have some anti-foam in there. Your engine oils are going to have some dispersants. Some of your gear oils and things like that are going to have these EP additives. These are extreme pressure agents. A lot of your engine oil, all your engine oils have a lot of detergents in there. You know, if you're in areas, these EP and anti-wears, a lot of times they're the same additive. I argue with oil vendors all the time about this, but they're the same additive. But a lot of times in your AWs, there may be 3 or 4 times more phosphorus than you have in your EP oil, but it's the same additive. If you're in areas where there's high moisture, lots of humidity, we may want to ask about rust inhibitors and corrosion inhibitors. I'll tell you how those work. All your mineral-based lubricants have what's called oxidation inhibitors in there that keep the oil from oxidizing. So maybe high temp will cause your oil to oxidize or high moisture. So we want to make sure these additives are in there. But again, knowing what additives are used in your oils lets us know what to test for in your oil analysis program. Sometimes you'll want to ask the vendor. I've been with vendors that are really reluctant to tell you what additives are in there, but you can just send a sample into the lab and they'll tell you. You know, most additives can be replaced. You know, a lot of power plants where they have very large reservoirs full of oil that they're pumping around equipment, they actually add or change additives. Those additives are going to become available for your drums and some of your equipment in the next few years. They're actually available now. There's just not a good marketing campaign, but you're going to be able to add additives to your existing oils to get extra protection, maybe to get rid of some foam. But again, very important for the additives to be correct and present in your lubricants that are used in your aging equipment. So a lot of times when I run an oil analysis sample, that's the very first thing I look for is what additives are left in the existing oil. So if you look at some common systems, hydraulic systems, they can have corrosion inhibitors, antioxidant, anti-wear, anti-foam. They can have some viscosity improvers. But look at that, a hydraulic system, 1 to 5% of the oil is additives. You can see your worm gears and spiral bevel gears, 3 to 8, 1 to 10% of the oil is additives. Engine oils, if any of you are using mobile equipment, your engine oils, especially in the mining industry where there's a lot of mobile equipment, you know, engine oils, the additive package is 10 to 25, and some people tell me it could be up to 30% additives. Now, one of the things I'll just mention while everybody's on here, but if you've ever changed oil in a mower or your car, and if you remember how slowly oil comes out of that plastic container at the very end, that slow stuff coming out the very end is additives. So you want to always shake up those containers, those small containers, and you'll notice when you dump them out then, everything comes out pretty fast. But the point of that is, where do you think the additives are in the drums of oil you've got stored in your oil rooms? Well, a lot of times those additives will settle to the bottom. So we need some way to mix those additives up, or you can just hire some great big guys that can shake drums. But most of the time we want to put some equipment in to mix those additives up because they'll lay on the bottom and you won't get an even distribution of additives in your equipment. So again, understand what these additives are. You know, the one here, like I said, the antioxidants in all your mineral-based lubricants. They prevent the formation of acid, sludge, and varnish that result from oxidation. Antioxidants prevent the oxygen from attacking the base oil and causing organic acid buildup. It says here, oxidation cannot be prevented, it can only be delayed. So once your antioxidant's gone in your oil is going to oxidize a lot faster, which means it's going to turn dark and become something that's not a very good lubricant. Your dispersants, what these dispersants do, especially in engine oils, they keep particles in suspension, they surround them when they're small to keep them from settling or growing and clinging to machine parts. You know, what dispersants do in an engine, they'll grab the particle, they'll keep it in suspension where it goes through the filter. The filter will take the particle off, and the additive will go on through to be reused again. If you don't have filter systems, a lot of times what you see in the bottom of a gearbox or a hydraulic system is where these particles have surrounded, or the additives surrounded particles, and it may settle in the bottom of your unit as a sludge. You might see that when you take a unit apart. That's what causes that. Detergents, a lot of detergents in engine oils, they keep surfaces free of deposits. They prevent the formation of deposits and remove previously formed deposits. Detergents are also used to neutralize acids in oil generated by combustion. Corrosion inhibitors. Now, your corrosion inhibitors, your anti-rust inhibitors, what they do is they form a seal in your machine surface that resists water from the surface and eliminate the formation of rust. So what these compounds do is they coat the internal surface of your components so that water can't get there and cause the surface to rust. So if you open up gearboxes and pumps and things like that, you see rust in there, that means that you don't have enough of this additive in there, or maybe the lubricant you're buying doesn't have any anti-rust or anti-corrosion additives in. So we have to look at this. Anti-foam. We've all seen hydraulic system where the oil gets milky and foamy. So anti-foam keeps the bubbles large so they go to the surface to be released. Without anti-foam, the bubbles remain very small and suspended in the oil. So like a lot of times you look at a hydraulic oil and it's milky and foamy, it's a good indication, you know, that your additive is depleted. And also it might be an indication you have some moisture issues, but moisture issues will also cause an oil to foam, and it also absorbs all your anti-foam. Your EP additives, like I said, EP and anti-wear additives. This is an additive used to improve lubricant performance in conditions where local high pressure may exist. So you'll see EP additives in oil and greases, but what they do is they'll actually lay down an extra surface layer of protection on the component. So if you have a gear that's running under, it puts high lube pressure, it's got some high temperature, the EP additive will actually lay down a surface on the component to resist wear. So very important, if you have gearboxes that are required to have EP in there, that you run your oil analysis report to make sure that additive is still present. Otherwise, when it's gone, you may have some increased wear. Anti-wear, like I said, is the same as the EPs. And like I say, a lot of times your vendor will tell you it's a completely different product, but I've actually run oil analysis samples where the oil I have, your EP oils from the same supplier will have 800 parts of phosphorus in there for the EP, and it'll have 3,000 or 4,000 parts per million of phosphorus in there when it's an anti-wear. But again, find out from the vendor what they're using for this additive and have your lab tell you what's actually in the oil. Rust inhibitors, like I said, the same as corrosion inhibitors. They keep moisture from attacking your internal components, or they protect it from moisture. So again, key thing here, we'll bring it up at the end of this thing, but understand what those additive packages are. Make sure the additive packages are actually in your new oils. I mean, Justin and I have sampled new oils that have no additives in there, which means the vendor didn't put them in. Sometimes the additive packages are too high. I don't really worry about that, but we at least want to make sure that they're in there if you're paying for them from the vendor. So what are some failure modes of our aging assets? Well, it could be wider clearances between bearings, bearing housings, and gears. What this causes is maybe some looseness, some extra wear that goes on. There could be some pitting on your machine surfaces, like your bearings and gears, where you get these small microscopic pits that are going to cause you maybe to lose your lube film thickness. There could be some looseness. You know, as things wear, as things get older, in our aging equipment, there's going to be a little bit more looseness, maybe a little bit more backlash. What if we're using some tools? We get some high ultrasound readings from friction in our components. You know, this is going to tell you some of the failure modes. Vibration analysis may tell us we have some movement. The temperature of the box, whether you're using a temperature gun or you're using an infrared camera, temperature is going to tell us that something's going on, right? We're getting more friction, something's going on. But, you know, whenever we had friction, whether we find it out from ultrasound, we find it out from temperature, that's something to do with lubrication. Where's that temperature coming from? We don't have a good lube film. We got the wrong lube. We got the wrong viscosity. You know, a bore scope. You know, I've been doing some work in the wind generator industry for a company, and a lot of times they take the wind generator gearbox, especially when they have some high iron counts in their oil samples, and they run a bore scope in there. And I'll show you a couple pictures of some gears and things that are worn. And then human senses. getting your operators and getting your maintenance people to touch things, feel things, listen to things, so we can find out what's going on. So these wider clearances says as equipment ages, clearances may in bearings, bearing houses, gearboxes, bores, and increased backlash on gears from wear. These wider clearances are going to cause us issues. These clearances increase, or the clearance increases causes components to wear at a higher rate and leads to earlier failures. So a lot of times, when you got too much backlash, we got too much space between there, whether it might be a bearing or a gear issue, it's going to cause for higher wear rates. Now, did these increased clearances come from lubrication issues or other failure modes? Was it some misalignment issues? Was it some balance issues? But a lot of times you're looking at gearboxes, you're looking at bearing wear in motors, some wear in hydraulic systems, many times. And like I think the average is 50 to 55% of the time, they're lubrication related issues that would have kept this from happening. Pitting of bearing or gear surface happens for a couple of reasons. Well, sometimes we lose the lube film or the component's overloaded, and this metal surface of the bearing or gear finally fatigues from overloaded normal wear, so we start seeing some pits. If we lose our lube film, for whatever reason we lose that lube film, whether it's the wrong viscosity or the viscosity changes, whether the lube is aged, because as our lubes age and oxidizes, as a lube oxidizes, the viscosity actually increases. Maybe there's a lack or a loss of the additive package for some reason. So we got to find out why we're losing our lube film. It's creating this pitting. But what pitting does on our gears and bearing, it reduces that surface area that's now in contact. So before we had pits, we had this nice big surface area. Now I've got pitting on the surface, and now I've got less surface area. This is going to create some extra loading in those areas, and it's going to reduce life, cause an early failure. But what this pitting also does is our lube film thickness that was there on that surface now has to go in and try to fill into a pit, which doesn't give us much carrying capacity, but also when we put that pressure down that pit from the lubricant, we can damage the component that way and actually make the pit or cavity bigger. I remember when I went to bearing school, I found out that, a lot of times on the loaded surface of a bearing or a gear, you can create anywhere from 20 to 50,000 PSI of hydraulic pressure. And that pressure pushing down these pits are going to cause the pits to get wider and cause more wear. So very important to inspect our components for that. Looseness occurs with wear and can cause parts to wear excessively fast. So we have to watch this. A lot of times we can find this out with vibration analysis and other things we hear with mechanical ultrasound. But looseness in equipment is a result of wear of internal components such as bearings, gears, shafts, etc. So again, looseness, how do we measure it? How do we find it? So we talked about these high ultrasound readings from friction, vibration or movement, temperature, bore scopes, human senses. These are things these are tools we have that'll indicate some of these things are happening. So understanding your equipment condition is very important to know what steps to take. Using technologies that can detect friction, movement, noise, and wear are important to determine your strategy on your aging equipment. So let's look at mechanical ultrasound. So this technology can detect noise that's generated from friction, in which most cases may indicate wear. And a lot of times it's going to indicate maybe the wrong lube, maybe it needs lube if it's a grease bearing. Maybe it's going to indicate that our lubricant's not perform when we get friction in a gearbox, motors, hydraulic pumps, and systems like that. But as components wear, such as bearings, gears, shafts, start to wear, the wearing component creates friction, which UE ultrasound tools can detect. So lots of good information comes from these tools. So here we see some technician up in the upper left-hand corner checking a bearing on a motor. Lower left-hand corner, we see a technician listening to some compressor valves. So that's the left-hand picture and the middle picture. The picture on the far right is a technician listening to a grease bearing. He's got a reading on his little screen right there. The reading's not very high, but as that reading increases, it tells him he has more friction, and maybe just a loop task will bring that friction down. So again, very, very good tools to find these failures at a very early stage. So these tools can over time develop trends that let you know how to react to the data, such as wear and friction. So the question is to determine what is causing the friction, what's causing the wear. Is it lubrication? Is it loading? A lot of times this tool will tell you that. And trends, the software with the tools are amazing. So this is a compressor valve, and you can see on this chart on the left here, that's what the compressor valve is supposed to sound like when it's new or functioning correctly. It's a nice, quick, short burst. And on the right-hand slide here, this compressor valve's worn. It's staying open a lot longer. The frequency is a lot higher. So we know if we track this data over time, we'll know when to make the change or when to make the repair on that compressor valve. And the same thing goes with the bearing. We can watch the trends. As the trend gets higher and higher, we may bring it down with lubrication, but at some point it's going to tell us that, well, it's not a lube issue anymore. It's a wear issue. And now we can plan to replace it. So high ultrasound readings from friction. Is the friction from a lubrication issue? It's going to tell us that. Could the friction be from wider clearances in our component? We may be able to figure that out. Is our additive package going? If we have enough data in our system, we can match the data from mechanical ultrasound with the data from our oil lab analysis, where we're using two technologies together. We might be able to tell that the noise is because we've lost our EP additive. Is the viscosity wrong? I mean, sometimes we can find out this. We can listen to a mechanical ultrasound. We can send an oil analysis in, find out that the viscosity's changed or the wrong viscosity is in there. So lots of ways to use this tool that'll lead you to help work with other technologies. You see thermography guys now carrying an ultrasound tool with them. So technologies are starting to work together. So there's no silver bullet technology for all your failures. We have to use these sometimes in combination. But what happens in a bearing when we start hearing this noise? If you got the loop film, like in the top one here, we've got a nice loop film. We may have a touch every once in a while, but if we maintain our loop film, there's no touching. As we start losing our loop film, now these little points and little valleys and mountain tips on our bearing start touching. And then eventually that roller or that bearing starts running across these big cavities, these big pits, the points are touching, and we start getting a lot more of that friction noise. Vibration analysis. So this technology can be used to determine if there's movement. How much movement? What direction is the movement? So this can be an early life detection of a potential failure that may be happening. So vibration analysis, another good technology. So in vibration analysis, just some common terms, amplitude is how much movement's actually occurring. So if your vibration technician comes in and says you have 8 mils of amplitude or 8 mils of displacement, that means that component's actually moving 0.008 of an inch. So how often it's moving in vibration analysis is called frequency. So let's say your vibration technician says you have 8 mils of vibration at 1 times RPM. That means on an 1800 RPM motor, it's moving 0.008 of an inch 1800 times a minute because it's at 1 times RPM. And then sometimes we may want to know what direction it's moving. Is it horizontal up and down? Is it vertical side to side, or vertical up and down, horizontal side to side, or axial? So again, depending on where the vibration technician puts his sensor, the movement could be up and down, the movement could be sideways, the movement could be axial on the face of this gearbox. So all these things we can determine with vibration analysis, and it tells us what may be happening in the equipment. So if you have a lot of 1 times RPM, which means it's happening every revolution on an 1800 RPM motor, that 1 times RPM usually indicates imbalance. Misalignment, where you have misalignment where a coupling's not lined correctly or you have a bent shaft, that's going to happen twice every revolution. So 2 times RPM is normally misalignment or a bent shaft. And then 3 times RPM could be looseness, loose bolts, a loose base, cracked base. I mean, all kinds of things that this technology can tell us that's happening to our equipment. So very, very good technology to tell us something's going wrong. But if we look at the impacts of vibration on bearing life, it shows here on the left-hand side, if we can reduce vibration by 10%, it increases ball bearing life by 37%. It increases roller bearing life by 42%. Look what happens if we decrease vibration by 25%, 137% more bearing life. So again, vibration has a huge impact on bearing life. So lots of studies done around some of these curves here to show that we better be reducing vibration in our equipment. Thermography. or whether you're using a thermographic camera or just taking temperature readings with a handheld temperature gun. So it says, even though temperature issues are a later indicator of wear, because now we have friction, we're developing temperature, it's still a very important tool to determine wear or friction issues. So again, don't discount thermography. If you look at this motor, on the right-hand side, it's a motor down in a grain elevator pit, no guards around it. Not many maintenance guys are going to go down there and put their hand between the belt, but we can see with the camera that the motor bearing on that motor is hot. Here we have a shaft-mounted gearbox. Looks normal in the picture on the right, but we can see the shaft-mounted gearbox has got it's about 150 degrees on the picture on the left. Something's happening there. Is it a lubrication issue? Can a lubrication issue solve it? If we look here, here's a fan. We've got a pillow block bearing on this fan up here. We're showing a little bit of temperature here, not much yet. Motor's showing some temperature, but again, we can monitor. Then that's what's nice about thermography. We can take these pictures, we can monitor these things month to month. But this may be a direct indication that this bearing, this pillow block bearing, may need a little grease, may need a little lubricant. How old is the component? I don't know. How old is this motor? We don't know. But again, finding things early on our age of equipment is going to help us solve some of these problems. You know, some of the new software that's out, you know, from electrophysics, you take this picture, we can go back to our office now, we can move this little circle around the picture. We know what the temperature of the bearings are in the motor. We know we got a little bit hotter spot here on the motor, but we can watch this month to month on this motor, and we know if we've got changes or issues coming up. So software, very important in thermography also. Borescopes. Borescope technology can give us a visual indication of what wear may be and what component may be the issue. In the wind generator industry, borescopes are used quite often to look at the internals of generator gearboxes. So here we can see, inside here we can see this little pit with our borescope. If you look at the borescope here, we can see some gear wear. You can see some gear issues on the teeth, a little bit of pitting, a little bit of staining here. So again, with the borescope inside of a gearbox, you know, we can see we have some issues. Now, maybe this is not an issue that's going to cause us to fail, but you know, one of the very first things I notice here, it looks like a little bit of rust or stain here. So I'm going to go back in my oil analysis report, make sure I've got my anti-corrosion, anti-rust additive in there. You know, I've got some scraping here. So these lines here are caused from foreign material particles, something scraping. I would say here we're losing our lube film. It's a pretty direct indication. Some of this pitting here is from foreign material particles. So again, the borescope is going to tell us, give us some good, easy information on what we should be doing. And then don't forget this one. Everybody that's on here needs to know that at times we need to go out to our equipment. Our operators around this equipment more often than anybody else, you know, what can they hear when they're there? What can they feel? You know, is there anything that's smelling different? You know, things that we can find in the very early stages. Now, we're going to find it a lot sooner with predictive technologies. But, you know, when, you know, companies that say I'm not going to do PMs anymore because I'm using a predictive tool, well, some things you're still going to have to use some human senses on. The technique requires some training, right? And it also means they have to actually get out of the control room. They have to be close and intimate with our equipment, so we have to train them on where to put your hand on the equipment, where to listen, what they might feel, what they might see. You know, it's the understanding of these issues that from human senses. But again, all kinds of things we can find out. You know, I had my operators at my plant. We had to put our hands on the motor every week on to make sure there's good airflow across the motor. The motor's clean. There wasn't any vibration. The motor wasn't a lot hotter this week than it was last week. But again, lots of training went into this. So now we get into some remedies. So is the viscosity correct for the aging asset operating conditions? We talked about that one. One, you need to go back and check. Again, look at your temperature curves. Look at what viscosity may work better. Again, sometimes you may have to go back to the OEM. Sometimes you need to call in another professional, but sometimes maybe changing the viscosity will help those operating conditions. So look at temperature, moisture issues that affect viscosity, age of the lubricant. Remember, viscosity increases as the lubricant gets older and the lubricant oxidizes. So as that lubricant oxidizes, as it gets darker, the viscosity will start going up, which may create an issue in your equipment. Now, here's another one. As lube oils oxidize, the acid number is going to go up. So there's a lab analysis test called the total acid number. This is used a lot of times with gas turbines. It's used a lot of time with mobile equipment in the mining industry. As that oil oxidizes, as it gets darker, one of the things I tell people in the mining industry when they're looking at engine oils, the real key thing there is what is the acid number? Because what happens as the acid number goes up, the oil can become acidic, and when it becomes acidic, it can actually start eating your equipment components, especially in stuff that runs hot, like gas turbines and mobile equipment. So lots of things we need to look at with our oils. We talked about the additive package. What's the additive package in the lubricant in your aged equipment? Remember, like I said, things that were specified in the 1970s, 1980s, some of these additives may not even have been available. So maybe you want some more phosphorus for your wear protection. If you got corrosion or you see some rusting inside your equipment, you might need some more anti-rust or corrosion additives in there. If you've got high temperature applications, stuff that runs hot all the time, maybe we want to put some more antioxidants in. Like I say, there's some companies making your antioxidants in the little squeeze packs now, where you're going to be able to add antioxidants. So these are all things we need to understand and look at with our packages and our aged equipment. What are the moisture issues? If you got high moisture, it says moisture reduces the lube's capacity to maintain the correct lube film. So the higher moisture level that you have in your lubricant, the less loading capacity that lubricant can handle. Moisture can also change viscosity. Once the moisture starts mixing with your oil and that oil goes through hydrolysis, the lubricant becomes something that's not a very good lubricant anymore. Another thing moisture hurts us in our lubricant, it absorbs and actually eliminates a lot of your additive packages. So we have to watch the moisture in critical equipment. So, moisture filters, desiccant breathers, all kinds of things that we can use to keep moisture out. But if you look at this chart, the effects of moisture on roller bearing life. So if we go to the left-hand side of this curve, we can see if our oil's got 1,000 parts per million of moisture in it, and we can come across here and let's say we can get that moisture level down to 100 parts per million. Look, it adds 3.3 times life to your equipment just by reducing the moisture level. And I think if you go down to 50 parts per million, it gets up around 5 times more life. So moisture has a huge effect on bearing life. Again, we talked about particles. How many particles are in the lubricant? Particles increase wear and shorten equipment life. Filter lube to the lowest ISO levels for long life. Look at this chart. Let's go back to our 22-19-17. It's kind of a middle range dirty oil. But if we can filter it down to this 16-13-12, whoops, it shows here for roller bearings, that's whoops, I'm on the wrong one again. Sorry. That's it's about 3 times more roller bearing life. So again, very important. And you can see the cleaner we get our oils, if we can go down to a 5 micron fill, we get 5 times more bearing life. So again, check your ISO codes in your gearbox and bearings, get those levels down. So again, to wrap this all up, understand your current conditions. How old's your equipment, what kind of condition it is, what kind of things can we detect with our equipment. Look at your lubricant life and issues. Is the viscosity additive package correct for the equipment conditions? So this is something we have to go back to our vendors on. If you can always email me and ask me some questions about this if you need to. But again, use these diagnostic tools. They give us so much information. Your UE mechanical ultrasound tool, your vibration tools, your oil analysis tools, your thermographic cameras and temperature guns, all kinds of things. And some of these tools are getting cheaper. Vibration analysis tools, I used to remember they're in the $50,000, $60,000 range. You bring in a highly trained technician. Well, now you can buy a good vibration tool for under $2,000 that gives you some of these readings in 1, 2, and 3 times and do some of these things yourself, but use the tools. Somebody told me one time I can't afford to buy a UE tool, and it was a $10,000 tool. And I said, you just had a $25,000 failure and you were down a day and a half. So, when's the next one going to happen? So you tell me you can't buy a tool. So the tools have a huge payback if you start looking at downtime. So again, that's my presentation for the day. I'm hoping everybody got something out of it. If you have questions, you can email me, or Maureen may take some questions now.
Yep, awesome. Thanks, Terry. Great information as per usual. So yeah, a couple questions coming in, and we've got some time, so if folks have some additional ones, feel free to type those in. But someone was wondering, if we try to mix additives, aren't we increasing the probability of contaminants in our oils?
Well, the additive package that the new vendors are coming out with are in little squeeze packs. And so you just basically cut the top of the squeeze pack off and put the additive in there while the equipment's running and it mixes real well. So they've reduced the opportunity, or they've reduced the amount of chance that you can get particles in there rather than having a jar or something you just dump it in.
All right. What size was reservoir? Oh gosh, I've got. Let me try that again. What size reservoir? I don't know why that seems to be a hard word to say today. Would typically be cost beneficial to replace additives over a drain and refill? I don't know if I quite said that right.
Up to just a couple of years ago, the power plants that had the 2,000 and 3,000 and higher reservoirs where they pump lube around different equipment, that's the only people that were doing it. Some of the additive blenders now that are putting them in the squeeze pack, they're getting down to the 50 and 100 gallon reservoirs, like on hydraulic systems and larger gearboxes. So, and that number is probably going to go down over the course of the next couple of years, because they'll blend the little squeeze pack for the size of reservoir you have.
All right, and one last one before we wrap it up. And of course, people, you see his email there. You can email me with questions, and we'll get them over to Terry. But what does the cleanliness code mean in reference to aging equipment?
Well, the lower the numbers, the less wear you're going to have in your equipment. So I don't know if the cleanliness code, when I tell people the best time to put the cleanest lubricant in your equipment is when it's brand new. So some people say, well, my equipment's already worn and I don't need to worry about it. But if we can get these particles down in our equipment and keep them down, even your age components are going to last a lot longer. So the lower we can get the cleanliness code, the longer your equipment's going to last. So I always recommend people start out with a 10 micron beta 1000 filter, and we go and you can get that gets you down to that 16, 14, 12 in that area. And then as you get your system cleaned up, you might be able to go down lower than that even.
All right, awesome. Well, in the interest of wrapping this up on time here, just want to say thanks again, Terry. Again, if you've got questions that we didn't get to, we'll be sure to get those to Terry and get those answered. Just a quick shout out for us. Our conferences are coming up, Ultrasound World and Reliable Asset World. Terry is actually going to be down presenting on a similar topic. So this is kind of the presentations you can expect to hear at that. But really great event. Awesome location. We're looking forward to being back down in Clearwater Beach, May 14 to 17. So if that's something you want to take a look at, you've got the websites there. I'm sure you've also gotten my emails about it. And I'll leave our contact info up here for a little bit. So like I said, lots of ways to get in touch with us. We're always happy to help out. Hopefully this has been helpful to you all, and we'll be in touch soon with what we're going to be talking about in March. But Terry, thanks again, and everybody have a great day, and we'll catch you guys later.
All right, thank you.